In this video, let's take a look at creating some boundary surfaces by using 2D and 3D sketches. Now on the screen we have three sketches on various planes. Now if we take a look at this from our top view, you'll notice that sketch 1 and sketch 2 intersect at the endpoints. So it would be very easy for us to create a plane and create some curves on it to help go between these two for our direction 2 inputs. But you'll notice that sketch 4 doesn't have any intersection points where we can create a plane and easily create curvature to go between there. In cases like this and various other cases, you might choose to use 3D sketches. So let's go ahead and create a 3D sketch and take a look at how to create some of this geometry. So as I mentioned in a previous video, we talked about the stipulation when you're using direction 1 and direction 2. You must have an intersection point between direction 1 and direction 2 curves, and it must be between every curve. So if we plan to use all three of these curves, we would not be able to create a direction 2 reference simply by going around the second curve. Without having this intersection, we would not be able to use this as a valid input. But we could go ahead and create a reference between these. Now you'll notice that it's saying it's overdefined because I tried to make an insertion or a coincident point between the endpoint of our sketch 2 and the spline that we just drew. In order to get around this, we need to go ahead and insert an additional spline point. So you can either draw that at the time you're creating your spline or right click on it and insert an additional spline point. Now we can create some sort of relation between those to make them coincident. We can still use the end handles to create all the curvature, but you can see that we're going to have some influence from that point because we have a coincident relation. We can do the same thing on the other side, create a spline simply by grabbing all three of those points. We can also do this by creating a spline in the middle as long as we intersect all the points. This doesn't have to follow any sort of 2D relation. As long as it intersects all the curves, we can use it as a valid point. And you can take a look at this from different views, and you can alter the curvature in each of those views. For instance, if we wanted to tweak this out in the Z direction, we would be able to do that. So let's go ahead and exit this 3D sketch and take a look at creating a boundary surface from these inputs. So we know we want to go from this curve to this curve to this curve. And I just want to make a quick note, on the left-hand side of our inputs, we have up and down arrows. If for some reason your input selection was improper, for instance, if you grab sketch 1, sketch 4, and then sketch 2, you can see that it's trying to loop the surface back around to itself. So instead, you would have to reorganize your inputs to make sure that the input selection process follows how you want the surface to be created. Let's go ahead and just drag these out of the way so we can see a little bit better what's going on. So you'll notice that we need to make some direction 2 selections, and all of our direction 2 curves are actually in one single sketch. So when I select this, it's going to instantly pop up our selection manager to make sure that we're selecting the appropriate curve. So you'll notice I selected one curve and it's created an open group curve because it's part of a sketch that contains multiple curves. And that's okay. If we want to use more, we can simply select another one and OK it in our selection box. So you can see we were able to use all three of these curves that we created, even though they're in 3D and they're not on a plane, and we were able to introduce some extra curvature into our surface. So let's go ahead and hit OK and take a look at what we've created. Obviously, there's quite a bit of curvature added to this surface, but the outside boundaries are contained by the direction 2 curves or the guide curves or paths, whatever you like to call them. The middle of our surface is heavily influenced by that guide curve or that direction 2 curve that we made that had all that extra curvature in the Z direction. So this is a real great way to introduce a lot of curvature by creating some 2D sections and then going back and creating some direction 2 3D curves to help introduce that curvature that you want.